We're about to go on a journey to a place that, by all rights, probably shouldn't even exist. It's a realm of pure darkness, of impossible pressures, of violent, beautiful creation. Welcome to the deepest point on Earth. Welcome to the Challenger Deep. Let's start with the number, 10,935 meters. Just let that sink in. We're talking almost 11 kilometers straight down. You could take Mount Everest, flip it upside down, and it still wouldn't touch the bottom. This isn't just a measurement, you know? It's a descent into an entirely different reality, a fundamental tear in the very fabric of our world. And with that kind of depth, you get pressure. The sheer weight of all that water is over 1,000 times greater than what you and I are feeling right now. To put that into perspective, imagine an elephant balancing its entire weight on your thumbnail. Now imagine that same crushing force on every single square inch of your body. It's a relentless, world-defining pressure that dictates every single thing that happens in the Challenger Deep. So here's how we're going to make our descent. First, we'll look at the powerful geology that created this place, the subduction engine. Then we'll dive into the truly bizarre physics of it all. After that, we'll meet the incredible life that calls this place home, and we'll even listen to the sounds of the deep. And finally, we'll face the most disturbing discovery of all, ourselves. Alright, our journey starts with the architecture of the abyss itself. See, the Challenger Deep wasn't just formed. It is being actively, violently, and constantly forged. We're looking at a workshop of planetary mechanics, and the process is just beautiful destruction. What you're looking at is basically a scar from a collision so slow and so powerful, it's almost impossible to comprehend. The colossal Pacific tectonic plate is literally crashing into the smaller Mariana Plate. This impact has been going on for millions of years, and the trench? Well, that's the deep, permanent wound from this geological war. At the heart of it all is one key process: subduction. What's happening is the Pacific Plate, because it's older and denser, is being forced to dive down, to plunge right underneath the Mariana Plate and into the Earth's mantle. The planet is literally consuming itself, recycling its own skin. This is not a static landmark, it's a live engine of chaos, the primary force shaping this entire world. And you can see the results of this chaos everywhere. The insane pressure and chemical reactions from that diving plate create things like these serpentine mud volcanoes. The Earth is basically exhaling chemically altered rock from deep within. At the same time, the constant grinding of the plates generates deep focus earthquakes, a planetary shudder that keeps the very foundations of the trench trembling. Okay, let's go deeper. We're leaving the geology behind and entering a realm where the fundamental laws of physics are just pushed to their breaking point. Down here, the rules we know on the surface, they're broken and completely rewritten. Just think about the water itself for a second. Under 1,100 atmospheres of pressure, the water molecules are physically squeezed closer together. The water becomes about 5% denser. The very medium of this world is fundamentally different from anything we know up here. And then you have the temperature, which is a total paradox. Most of the trench is this stable, near freezing darkness, right? Just a couple of degrees above zero. But because this is such a geologically active place, you also have hydrothermal vents blasting out superheated water at 400 degrees Celsius. Just imagine that, a world of frozen night existing right next to volcanic fire. That is the chaos of extremes. And here, the ocean's chemistry itself becomes this architect of chaos. See, below a certain point, the calcium carbonate compensation depth, the intense pressure and chemistry of the water become corrosive to calcium carbonate. You know, the stuff that makes up shells and skeletons. Creatures down here literally can't build armor the way they do in the upper ocean. It would just dissolve. The environment itself forces life to find completely new ways to even build a body. So, in a place with crushing pressure, freezing cold, volcanic heat, and corrosive water, life shouldn't be here. It just shouldn't. And yet, it is. In fact, it's thriving. And that's the great paradox of the Challenger Deep. We're now entering the realm of biological masterpieces, creatures that were engineered by chaos itself. And here it is, the undisputed champion of the deep. Meet the Mariana snailfish. It looks so fragile, right? Almost like a ghost. But this animal lives its entire life at depths that would instantly turn a military submarine into a crushed can. It is a living, breathing testament to the unbelievable tenacity of life. So how in the world does it do it? Well, its body is just a collection of brilliant workarounds. It has no scales, its skeleton is incredibly flexible, and get this, its skull isn't even fully fused together. It has gaps that allow the pressure inside and outside its body to equalize. It doesn't fight the pressure, it just yields to it, becomes one with it. But its biggest secret? That's on a molecular level. The snailfish's greatest weapon is a chemical called TMAO. See, under the abyss's intense pressure, the proteins and cells of a normal organism would just be crushed, twisted, and stop working. But TMAO acts like a molecular scaffold. It holds the snailfish's proteins in their proper shape, allowing them to function. It is the secret ingredient, the chemical key that makes life possible in the impossible. And the snailfish isn't alone down there. Other creatures have come up with their own wild solutions. You've got these giant amphipods, which look like supersized shrimp, and they've actually figured out how to pull aluminum from the water to create a kind of gel-like armor. And then there are xenophores. These are huge, single-cell organisms that basically act as the deep's janitors, filtering sediment and concentrating heavy metals in their bodies. Now, you would think a place of such immense pressure and total darkness would be silent, like a tomb. But that couldn't be further from the truth. The trench is alive with sound. It's a constant hum of planetary chaos. The unique V shape of the trench, combined with the incredible density of the water, turns the whole thing into a natural acoustic chamber. Sound travels unbelievably well down here. So instead of a silent void, it's a place that captures and funnels noises from thousands of miles away, from the surface all the way down to the very core of the Earth. If you listen closely, you can hear a whole symphony of the deep. For a while, scientists were picking up this strange sound they called the biotwang, which they eventually figured out was a complex call from a minke whale. But underneath all that, there's a constant low-frequency rumble of the subduction engine itself. That's the sound of the tectonic plates grinding against each other. Add in the noise from distant earthquakes and even the propellers of ships way up on the surface, and what you have is a surprisingly loud world. So we've explored the geological, the physical, and the biological chaos of the deep. But our descent has one last, unsettling stage. Because in this most remote, most alien place on our planet, we're about to find something disturbingly familiar. We are about to find us. What scientists found inside those giant amphipods we mentioned, it's just chilling. Their bodies contained incredibly high levels of PCBs, toxic industrial chemicals that were banned decades ago. The concentration was actually higher than in crabs found in some of the most polluted rivers in China. The chemicals we created have sunk to the bottom of the world and have worked their way right into the food web. And it's not just our chemical signature, it's our physical trash. On expeditions to the very, very bottom, what do you think we found? A plastic bag, candy wrappers, the most mundane, disposable artifacts of our lives on the surface, just sitting there in the deepest, most inaccessible place on Earth. The contrast is, it's just sickening. Let this really sink in for a moment. Every single major expedition that has ever reached the bottom of the Challenger Deep has found our garbage. There is no pristine wilderness left. There is no away where we can throw things. Our footprint, our scar, is now etched into the deepest scar on the planet. The final layer of chaos, it turns out, is the one we made. And that just leaves us with this profound, really troubling question. We journeyed to the Challenger Deep expecting to find a world of alien chaos, a place totally removed from us. But in the end, we found a mirror. If our presence is felt even here, in this realm of impossible pressure and eternal night, then what does that say about the rest of our planet? And more importantly, what does it say about us?